Hello there. This is lesson 2 on chapter B9 respiration. Last lesson you learned about aerobic respiration, and this is a chemical process that takes place in the mitochondria of all of your cells. They produce energy required for many things that goes on in your body, but it's precisely when you exercise that this energy is needed the most. So today you are going to learn the response of your body to exercise in order to facilitate the production of this energy in mitochondria, and so you can keep exercising. The first image is showing you a muscle fiber contracting. When you exercise, your muscle fibers contract much faster, and these will need more energy. As a result, more glucose and more oxygen will be needed to produce that energy, so your muscles keep contracting, and more carbon dioxide and water will be produced as waste materials. As a result, your body needs to present with solutions to bring about more glucose and oxygen to the muscles, but also to remove as fast as possible carbon dioxide and water from them. As you exercise, more oxygen and more glucose are needed to produce energy. The same way, more carbon dioxide is produced and it must be removed. By increasing the heart rate, this is ensuring that your muscles will get more glucose and more oxygen, but also carbon dioxide removal. And by increasing the breathing rate, you are ensuring that you are providing your muscles with enough oxygen to produce the demanding levels of energy to keep contracting your muscles, but remove this carbon dioxide from your body at a faster rate too. Now we are going to look at a little bit more detail those three changes in the body. Well, we've seen that the heart rate increases, but that's not all. In the cardiovascular system, your arteries supplying blood to your muscles also dilate, which means that they enlarge. With these two changes, we are ensuring that enough oxygenated blood is flowing to your muscles, so more oxygen and also more glucose are being provided to your muscle cells. And this is extremely important because you are needing more energy. So if you can get more of these reactants to your muscles, you can ensure that there is an increased rate of cellular respiration and more energy can be produced. But this also means that your blood is removing carbon dioxide from your muscles at a faster rate too. Your breathing rate also increases when you exercise, as well as breathing more deeply. This ensures that more oxygen is brought to your muscles and more carbon dioxide can be removed from your muscles. So by increasing this breathing rate, we are helping to provide your muscles with more oxygen and removal of carbon dioxide more rapidly compared to when you are at rest. As we've seen before, your muscles can store glycogen, and when you are exercising, this glycogen can be converted back to glucose. This happens because when you are exercising you need more energy, and one of the reactants for respiration is glucose. Increasing physical activity means more respiration. More respiration means more glucose needed. This graph shows the changes in the heart and breathing rate before, during, and after a period of exercise. On the y-axis, we have the breathing rate and the heart rate. And on the x-axis, we have the time. I'm going to ask you please to look at the red line, which is representing the heart rate. Before the exercise, the number of beats per minute is at a constant, but it suddenly increases when you start exercising. The number of heartbeats remains high during the exercise, and there is a drop in the number of beats when you stop exercising. This doesn't happen immediately, but more in a gradual way. And that's why it's called the recovery period, until you finally reach the number or the original number of beats per minute. I'm going to ask you now to look at the orange line, which is representing the breathing rate. When you are at rest, the breathing rate is at a constant. And when you start the exercise, the breathing rate starts increasing, although slower than the heart rate. When you stop exercising, the breathing rate starts decreasing again until it reaches the original number of breaths per minute. However, this happens much slower compared to the heart rate recovery.